Good evening, everyone. Am I audible?
Good evening, madam. You are audible, madam.
Okay, thank you. So, we are in week 4. So, today we will be discussing week 4 concepts. I hope you have gone through the lectures. Have you gone through the lectures?
Nobody is telling not much, madam. Started with lecture one, abstract data types.
Okay, fine then. Okay.
Ma'am, I have gone through the lecture, but it's not understandable. All the concepts are not.
Yeah. So, a lot of concepts are discussed in week 4. So, today we will be discussing some, if possible, some 3 concepts according to the time we have. So let's start. Uh, I think the last 3 lectures, if you are finding difficult, just watch again. It will be easy only, but first time you will find little bit difficulty. So I think then if you have started going to the lectures, first 2 concepts, abstract class and interfaces will be easy. Anyway, I'll start from the basic only. Hope my screen is visible.
Yes, ma'am.
Okay. So in week 4, the concepts include first concept is abstract classes, then interfaces, and then inner classes, then uh, how we can deal with private inner classes through some other way. Then we have iterator. Yeah. So starting with abstract class. So you have already gone through the inheritance concepts. So those concepts will be used here too. Anyway, first I'll take you through abstract class. Abstract class. So one specialty of abstract class is we cannot create object of abstract class. We cannot instantiate or create object of abstract class. But we can use reference variable of abstract class. And there are certain uses of abstract class. We'll see that. Let's define an abstract class now. So how normally we define a class as class. Let me take the same example, shape. Okay. Suppose we have class shape. We can have some instance variable here, right? Some instance variables. Then you can also have some methods. Okay. So this is our normal class. So how will we use this class? How will we use? We will have some public class, or in the same class we can have our main method. Anyway, I'm separating it out. So this is my example one. And here public static void main string. And here I can create object of shape class. Okay, this is our normal irregular class. Now, when I make this class as abstract class, so what we have to do is you have to use this keyword abstract. Now this class shape is actually abstract class shape. So when we restrict, so this is a restriction to our class shape. So first itself we discussed that we cannot create object of abstract class. Now you can see an error here. Cannot instantiate the type shape. Okay, then what is the purpose of abstract class? We'll see that. Before that, I'm going to add one method here. Okay, let me add a method public void draw method. Okay, and I'm making this method as abstract method, public abstract void. And now you can see here there is an error. Okay, what I mean by this abstract method is, now for this particular method we have not given a body or an implementation. What is this method doing? It's doing nothing here. So the implementation of method is not given here. The draw method is an abstract method. The implementation is not given. So who will give the implementation for this particular method? Any class that extends, inherits this particular abstract class shape. Okay, now see here, the type circle must implement the inherited abstract method shape.draw. So as this class circle is extending this abstract class, and as this abstract class has an abstract method draw, now it is mandatory for you, for one who write this class circle, to give an implementation for the method draw. So here you have to provide the implementation for draw method. I am giving some print statement, drawing circle. Okay, so we have class circle that is extending our abstract class shape, and here we have given the implementation for the draw method. Now instead of shape we have circle class. So using the reference variable of our abstract class, that is fine, but the object is of type circle, which actually extends our abstract class shape. Okay, now let me create one more class rectangle. Again, class rectangle is going to extend this abstract class shape. Here again I am going to, you can see again we will get an error, type circle dot rectangle must implement the inherited abstract shape dot draw. So here rectangle also has to give implementation for our draw method. Okay, now here I am going to change the implementation to rectangle, because here I am going to draw rectangle. It's just a simple example. So according to circle, I have implemented draw method for circle, and according to rectangle, I have implemented the draw method for rectangle, class rectangle. So you can now conclude, or get an inference. What we have, this abstract class which is serving like a base class or a template class. This is like a template class. In the beginning we learned that class itself is a template. Now we can say this abstract class is template class for another classes. What does it mean? All the other classes, the subclasses, circle, rectangle, or any square or anything that extends, that inherits this abstract class shape, is going to implement this particular method. So whichever classes that is going to extend this class shape is going to implement the method draw. So all the subclasses will have the same draw method, right? So we can see it as like a template. Are you getting it?
Madam, is it necessary that whatever methods the abstract class is having, it should be there in the subclass also?
Yeah, whatever abstract methods that an abstract class is having, that must be implemented by the subclasses.
Okay, you have one more abstract class called something in the shape class, then that also should be there. Otherwise, this circle class also will not work.
Yeah, right. So suppose we have paint Now we can see an error over here in circle, rectangle and square. All three of these classes must implement the inherited abstract method paint from shape. So whichever abstract methods that is present in the abstract class, that must be implemented by the subclasses, the child classes. Clear?
So this abstract class can also contain methods which are not abstract.
Yeah, right. So the addition thing for abstract class is from a regular class is abstract methods. Rest everything is similar to normal regular classes. You can have normal instance variables like int a, etc. You can have simple methods like public void, paint with implementation. Everything is allowed. One additional thing is abstract classes can have abstract methods, which means abstract classes can have methods without an implementation. The implementation can be provided by the subclasses. We can say in that way also.
Ma'am, what is the purpose of these abstract classes?
Yeah, mainly as a base class or a template class. So so that all the subclasses that inherit the abstract class, if there is a requirement where the subclasses has to implement a common method by all the subclasses, then you can make an abstract class and you can give this as a template class so that whoever develop the subclasses will follow the same, uh, will be in uniformity, like all of them will implement those methods to maintain that uniformity.
Okay.
Yeah. Now, one more compiler error that you will get is if you remove this abstract keyword, okay, and if a regular class has an abstract method, then it will give an error, which means if your class, if a class has at least one abstract method, then that particular class must be abstract class. Just keep in mind, uh, in quiz 1 maybe you will get some question like voice. Okay. And what about the other case? Suppose we have an abstract class, we defined a class as abstract class, but we do not have any abstract method, that won't give any error. Okay, just compilation, yeah, some rules. Is that fine?
So, ma'am, we can have an abstract class with no abstract methods.
Yes. Syntactically, it's allowed. So when I call s dot draw, what will I get? Wait, draw. This is for this is for this. Class square, draw as rectangle. Here we have not closed. Okay, now we got for s dot draw as it is circle, we are getting drawing circle. What is this concept? Runtime
Dynamic,
polymorphism?
dynamic
Yeah, dynamic dispatch, right.
dispatch.
Yeah. Okay. That is the main thing about abstract class. Any doubt you have here? Or shall I go to next topic?
Ma'am, can a subclass also be abstract?
Yeah, that you can have. You can make a class as abstract class here. And then you don't have to implement this method. I mean, you can avoid implementing the method. Syntactically, it is allowed. Any other doubt?
Ma'am, you have mentioned something dynamic, something that can you explain that?
Yeah. So here see, for the shape is we are creating the object of circle. So what exactly happens when we have a line like this? So this part is for reference variable. So s is of type, s is a reference variable of type shape, and here new circle will actually create an object of circle in the heap memory, and s will point to circle. And during runtime, what it will check? It will create the object of circle anyway, and now it will go and check whether circle has the draw method. Yes, it has the draw method, and it will take this implementation for draw method. So runtime polymorphism or dynamic dispatch means during the runtime, it will decide which method to call. So that is how it works.
Ma'am, if a abstract class extends an abstract class, and there are some method in both the classes, where to implement those methods?
Then again, you have to create some subclass. That subclass has to implement the methods from the abstract class.
Both
Suppose,
the abstract classes.
yeah, right, yeah. Suppose this is abstract class. One here we have abstract class. Here again we have abstract class. If we do not give implementation for draw here, and if we have any extra abstract methods here, another subclass that inherit this particular class abstract class circle must implement both the methods from the abstract classes.
Okay.
Yeah. And suppose,
Madam, 1 second.
yeah,
See, actually, once it comes to, can you scroll down a little bit? It comes to s dot draw. It will go and see s is of type shape. Then it will go to the shape class.
mm,
Then only it comes back to the circle class. No, madam. That is how the compiler works, isn't
yeah,
it?
yeah. So during compilation, okay, so we can say it as a two-step process. So during compilation, what will happen is in line number 32, s dot draw, okay, when it's s dot draw, it will check what is of type as, what is the type of as, that is shape, and whether shape has draw method. Yes, shape has draw method. Fine, compiler process. Then during runtime, what will it do? So S is of type circle. So the object is of type circle. So the draw method from circle will be taken. So we will get the output drawing circle.
Okay, directly it will go to draw circle method only. It will not go to the shape. When directly
No,
it go to circle class, or it will go to the shape class first.
no, it will go to circle because after it creates object, it will check whether the object has draw method implemented. So during runtime, it will just check whether draw is inside a circle or not.
Okay, and
Yeah.
if draw is not there, then it will go to shape.
No.
No, in normal
Yeah,
general,
yeah. Normal dynamic dispatch that works. Yeah,
yeah,
right.
that is how, whether it doesn't, the
Oh.
compiler doesn't know, no, whether it is shape is of abstract or not.
Yeah, yeah. So I'll take one more example here. So suppose we have public void paint. Okay, this is specific to our circle. Okay, I'm adding an extra method in class circle, and which is not an abstract method. Here it is painting circle, and now I'm going to call s dot paint. See here we are getting an error. Let's see the story behind why we are getting error for s dot paint. Even though circle has paint method, still we are getting error, right? Why is it so? The compiler error? Because during the compilation process for s dot draw, yes, shape has draw method, so fine. But for s dot paint, as s is of type shape, it will check whether paint method is present here, but we don't have paint method in shape class, so that is going to give an error.
Okay, so now that's what my understanding. I was just checking, madam. So it
Yeah.
will first check the shape. In shape, it will check up whether this method is there or not.
Yeah.
If it is there, then it will come back to the circle and see any method is defined there. If method is designed, then as per dynamic dispatch, it will take off the circle. If it is not there, then whatever shape method in the shape class is there, that will be implemented. Correct, no, madam?
Yeah, right. But these are two separate process. Okay. What you understood is right, but you have to think about compilation process and runtime. Yeah. What is it? Running the actual execution as two different process. So compilation, it will check whether draw is present or not.
Okay,
So
okay.
compilation is successful.
So first compilation has to be done before
Ah,
runtime.
right.
During the compilation itself, if drop method is not there in the
Shape
original
class.
parent class, yeah,
Ah,
then it will give a compilation error. We cannot go
yeah.
to runtime at all.
Yes. Right. So
So
that is two
once it checks
process.
there and if it is available, it will be quite quiet. And while running, it will see whichever
Huh.
method has to be used, that will be used because of dynamic dispatch.
Yeah. Because of dynamic dispatch, it will check whether which object is created in the right side.
Right.
According to that, that method will be taken.
Super, madam. Thank you.
Okay.
So, ma'am, if this code has to work, we have to typecast this S to circle.
Yes. That we can do here.
Okay.
Here to make this paint to work, we have to typecast. So S should be typecast to circle. Now circle, yeah. Now we have typecasted shape S to circle. Now it is available for this particular line. This will work fine. After typecasting, now we can access paint method.
Okay. All
Hello,
clear.
ma'am.
Yeah.
What if like S will be of type circle? Then how it will check? First, it will go in circle during the compilation time,
Hmm.
and when at the running time, it will again go in circle. If
Yes.
there it is not circle, then it will go in shape or
Yeah.
all the and
Yeah.
variable present in the circle. Yeah.
Right. What you understood is right.
Okay.
So
Madam, if it will not give error when circle does not have the after typecasting and circle does not have that method, it will not give any error. It will go back to the parent class.
yeah,
Correct? Huh?
it will check in the parent, and if parent also doesn't have the method, then it will give an error.
So it will go to the parent class.
Yes.
Okay. Thanks, ma'am.
Yeah, the normal inheritance checking. Okay, and suppose we have another abstract class. mm, some 3D. Okay, and I think this is wrong. Okay, suppose we have another abstract class, and if this particular class circle want to inherit both classes, this 3D and this shape, but it is not allowed in Java, right? Java doesn't support multiple inheritance through classes. Okay, so for this we have one more concept which is called as interface. So okay, so Java doesn't support multiple inheritance, so Java introduced another object or class type of a structure called as interface. So let's see what is interface first. So how can we declare an interface? It's normal, just like our class, we have to use the keyword interface. And I will take the same example, interface shape. Okay. Now interface shape is just like our class shape. Okay. And I'm going to add the method draw. draw method. And here see, abstract methods do not specify a body. So here you can avoid giving an implementation for the method. And I'm going to remove this public also, because if you declare a method like this in interface void draw, then by default this is considered as this method is public and abstract. You don't even have to specify that method is abstract. So when we say a method is abstract, that method won't have an implementation. So this method is not having any implementation, and as it is inside the interface, by default this method is abstract method, and also the access modifier is public. So the method that we declare in interface is by default public and abstract. Okay, and okay, I will continue with the one class. Suppose we have class circle, same. And here, how can I inherit this interface? So this is just like class. So in class, we use extends keyword to inherit. So here you have to implement. This term is different, other keyword is different, implements interface shape. And here, again, we'll get the same thing. Type circle must implement the inherited abstract method shape dot draw. So the draw method, which is abstract, we have to implement here. So yeah, here I will show void draw and drawing circle. One more error you can see here, cannot reduce the visibility of the inherited method from shape. So by default this method is public and abstract. The default visibility is public. So in the subclasses, when we override or give implementation for the method, we cannot reduce the visibility. So when we say nothing, no modifier, this means it is no modifier package private. That is the access or visibility of this method. So here public to default, this we cannot do. We have to keep the visibility as such or increase the visibility, but we do not have anything more than public. So as this is a public method void draw, we have to maintain the visibility here public. So this is another thing to remember. We cannot reduce the visibility.
Hello.
Yeah.
Then here, earlier in line 6, you have written void draw. So is it like by default, is it private?
It's package private. When we say just void draw, then it is package private. So this, when it is package private, this cannot be accessed from outside the package.
From outside the package or outside of this class? Because it can be accessed outside of the class, right?
Sorry, repeat. Can we?
It is accessed outside of this class circle, right?
Yeah. Here we can access inside the package any classes we can access.
But not outside this file,
package.
right?
Yeah. No. Outside the file also we can access. See, we have done all these things inside this week 4 package. We cannot access in week 2 package or week 1 package, but we can access anywhere inside this week 4.
Okay, so to get access of this line like void draw outside of week 4, we have to provide public, right?
Yes, right.
And this is due to because of this interface thing, because it gives us a public. The line number 3 gives public by default, so that's why it cannot be private. It should be public.
Yeah, in this case, that is the reason. Here, anyway, the method draw is public, so we cannot reduce the visibility. Another rule. So we have to.
Madam, but during our first week 1 or week 2, I don't remember. In Java, anything it is not written as public. It is public or private. It is always public only, no?
No. It's package private. It will behave like public inside a package, but not outside the package.
Oh,
So I have added one video. You can go through that. Yeah, in detail we'll learn about access modifiers later, but for now, just go through this. Okay, after the session, it's enough. So the basic difference of a public class and a default class. When I say default class, I mean no modifier class. Okay. So yeah, we were discussing about this visibility, right? So when we have a public method in the parent class, the child class, we should maintain it as public. Suppose we have a protected method in parent class. In child class, you can increase the visibility. You can make it public, but you cannot reduce the visibility. Keep in mind, you can increase the visibility, but cannot reduce the visibility.
Ma'am, this thing is true for class and subclass uh, everywhere, or just in these interface things?
Everywhere, it is everywhere. Normal rule. Yeah. So now this is our abstract method. Okay, I'll add our class example 4. Okay, now same rule is applicable here, just like our abstract class. We cannot create object of interface, okay, but we can use the reference variable of interface. So shape s1, or I'll keep it as c1, equal to new circle 1. Okay, yeah, but because my interface is also shapey, because I have same interface somewhere else. Yeah. So this is my interface. This is the class that implements the shape interface. And here we have created the object, and you can call c1 dot draw method. Drawing circle. So this is just about our abstract method. What else can we include in our interface? Let's see that. We can also include a method that has an implementation, like a regular method in our classes. But when we declare something like, suppose we declare like public void paint, okay, and when we add implementation, for our method, a regular method, you can see an error. Abstract methods do not specify a body, because in interface, any method by default is taken as public and abstract. So if you want to have a regular method, then interface has one more keyword that is supporting for the implementation, to give an implementation for a method, which is default. So when you declare a method as default method, then you can give implementation for the method. So what is default method? Default methods, this is called as default methods. Okay, default methods. Default methods are methods inside the interface which has an implementation. Is it clear?
Ma'am, how is different this interface to that you have explained before, that abstract
Abstract
thing?
class. Okay. Uh, yeah, main difference is supporting multiple inheritance. So in abstract classes, we saw that we are not able to do multiple inheritance, but through interfaces, we will be able to do multiple inheritance. I'll show that. That is the main difference.
Yeah. Because previously class 1 extends shape means you can only extend shape. It cannot extend anything else.
Yeah,
Now it says implement shape. So one more class in circle, you can have implement shape 2 or something like that, which is interface again.
right. Suppose we have shape 2. Uh, yeah, we'll discuss. Can I do this later? Let me finish static method also, okay? I'll add that too.
Yeah,
Then
whatever
we'll
you are
discuss.
planning, madam.
Yeah, because multiple inheritance, next topic. So here, one more thing to remember is static methods and interface. What is static method? Static methods are whenever we have a method, a static method or static variable that is specific to the class or interface. So I can have something like public static void print.
Ma'am, is not
Shape.
this static is used we don't have to create that object.
Yeah, right. We can use a static method by just using the name of the class or interface.
We don't have to create that object of that set.
Yeah,
No?
right. So here, printing shape. This is a static method. Okay. So these three things. Yeah. And what about the variables? Can we include variables in interface? Yes, we can include, but it has a specialty. Let's see. Int I. Okay. When I declare int I, I'm getting an error. The blank final field I may not have been initialized. So this error is because by default in interface the variables are final, which means we cannot change the value later, and also it is public and also static, right? So three things. The variables in interface shape are or any interface is actually public, final and static. So you have to initialize the value for the variable. That is mandatory. Now we cannot change this variable because it is final. When we have a final variable, then it means a constant. Okay.
And it is by default, ma'am.
Yeah. It is by default final, public and static.
Hello.
Yeah.
Ma'am, if you have not assigned any value to integer I, then why it is giving us error? Because like there is like it is public and it is static also and it is final, like there don't no value has been provided to it.
Your question is why is it not allowing?
Oh yeah, like we have to initialize, na?
Yeah.
Earlier, if we are like providing int I only, it was giving us error, no?
Yes. Because it is a final variable. Because final variables has to be initialized always. Because
Okay.
we don't have to change it later. So we want to restrict.
Ma'am, the methods
Yeah.
paint and print shape, both the methods are abstract methods.
No. What is an abstract method? Abstract method means a method without implementation, right? Okay. But for our default methods are methods with implementation, and static methods are also with implementation. But specialty is this is static, which means it is specific to interface, and static methods cannot be overridden. Here, yeah, this can be overridden. You can give definition for paint method again in our class circle 1, but you can't give definition for the static method. Okay, so you have a default implementation, but still you will be able to give a new definition for paint method, normal overriding, method overriding. But method overriding is not supported for static methods.
Yes, ma'am.
Okay.
And what is
So
the
ma'am,
mean,
this default.
Mm.
what is the mean by this static variable?
Static variable. Again, static variable means that is specific to, for example, if you have a class with a static variable, that means a global variable. Suppose we have a class student, sorry, no. Suppose we have class, okay, student only. And if that class student is having a static variable, uh, some roll number or count, okay, and this count variable will be common to all the student objects. So it won't be independent for each student objects, but it will be common to all the student objects. So if you make that any change for this count variable of the student dot count equal to 100, then that change can be seen from every object, which means it is common to every
Yeah. So
object.
section, like, is it like the section example? All the students will have the same section.
Huh. Or school name.
Yeah, school.
Okay.
Yeah. So we'll see this. Let's see how we can override paint method. So we can override paint.
Hello, ma'am.
Yes.
Like how instance variable can be final and static both?
How an instance variable can be.
Like final and static both. It should be either final or static.
Mm, am I wrong here?
If it is final,
Mm,
then it can't be changed, right? And the statics mean like any object can change that, and that will be
okay,
share.
okay. I think you got confused between what I told about the student object, right? Student class. Yeah, there what I meant about I just explained the static variables, normal static variable. Okay. So in that case, static variable we can change. A normal static variable we can change using the class name. Okay. When we have final and static variable, then we cannot change.
Yeah, that's right. Yeah, understood.
So okay. So here painting circle. Here we have overridden the default method. Okay. And let's try to override the static method. Why is it allowing? Shouldn't this give error?
Yes, ma'am, because static cannot be overridden.
Right, right. Mm, public void print shape. Static method. Is it taking the same interface or not sure why is it not giving error? But it should give error. Cannot over static method. Mm, here interface shape. That's a implement shape. Throw. Any idea what went wrong here?
Like we are not giving a static in the sub class, I think,
Hmm.
because signature should not be changed in the override.
No. But still no issues. But when it is static, we shouldn't be able to do it, right?
But ma'am, if we give the static also, like it will
Mm.
not showing the error.
Wait, if
Like if we provide the static as mentioned by someone, na, like
yeah,
signature thing,
but still it gave.
yeah,
No.
it will not throw error.
Yeah, and then that will be for the circle one, another static method. Wait, let me.
Ma'am, are you calling that S1 dot princess? Like,
No.
uh, okay. So I guess if you call that, then it will give us the error. Maybe.
No. We can call static methods using object also.
Yeah,
Yeah.
here C1 draw, it will go to draw method in circle directly, no, madam.
Yes.
So it goes to circle. Where is circle here? Only circle one is there.
Circle one. Yeah.
But circle, you have given new circle one only. One is also there. Okay. Circle one, it implement shape, public draw, system, draw circle.
But we should get the error right here. Mm, let's try to. Static void main. Yeah, the error is very different. Not sure what exactly happened. We'll come to that later. Okay. Let's see the rest of the concepts, which is multiple inheritance. Okay, suppose we have another interface shape 2, and here I have a default method paint again, and this draw 1, I'll keep it as draw 1 or draw 2. And here you can see we have two default methods with the same name. Okay, same paint, and I'm going to implement both interface here. CP2. Now see, here we are allowed to implement two different interfaces, which means this is multiple inheritance, but not through classes, but through multiple inheritance through interface. Okay, and what you have to do now, you have to implement the method that you got here, void draw 2. So again, public void draw 2, and you can give some implementation for the method. And yeah, what do you see here? We have two default methods with same name, right? Yeah, why multiple inheritance was not supported through classes? Because when we have two classes, okay, when we have two classes and the third class is inheriting these two classes, and a method in suppose there is a method in both classes which has same signature and same name, okay, then which method to call from the subclass will be a confusion or an ambiguity. So in order to solve that ambiguity, Java developers could not, not Java developers, one who developed Java could not find a solution. But here, but in this case, when we have methods with the same name, let's see how we will deal with that. So in interface, when we have two interface and child class is implementing these two interface, and if these two interfaces having same methods, so we have three different types of methods here, right? First one is abstract method. Suppose this shape is having draw method and shape 2 is also having the same draw method. How that ambiguity will be solved? Anyway, we will give implementation for this draw method in circle 1, so there is no issue. So that's how in interface the ambiguity is solved for abstract methods. And for default methods, how we will solve the issue? Suppose we have pain method and again a pain method here, same signature, same name, then but we have different implementation in two interfaces. So you have to give a new implementation for the pain method in circle 1. So that is how painting circle for default method. So you have to, this is like now mandatory, must implement default method to avoid ambiguity. So that is how we solve the problem for default methods. And for static methods, we don't have any issue because what we can do is we can use the interface name, along with that we can call it. And still, if you want to use the default method from the parent interface, how can you call the parent interface default method? You just have to use interface name dot super dot the method name. So that will call the paint method from the first interface. And for the second one, if you want, you can just use shape2 dot super dot paint. Now you can get the default method from shape2, the second interface. Getting it?
Yeah,
Hello, ma'am.
you can do all these things in our regular. I mean, if you are inheriting from two different classes,
Mm.
then the class name, and then you can give super, and then you can say it is whatever method you have to call. No,
But it's not allowed.
no, it's not
So,
allowed. But
uh,
actually, what is the purpose? Why the developers thought of like this? Because you are here anyhow, you are giving the main
yeah,
class name also here. I mean,
yeah,
parent class name. So even regularly, we can use the parent class name and then the method from that class.
yeah. But the problem was with I have read about this where they said if we allow the same thing in classes, that will increase, no, sorry, decrease the simplicity of Java. So they don't want to make it complex by adding those features in classes. Rather, they separated it into interfaces
And
completely.
I think I remember professors are telling in C, C++, and other
Mm.
languages, I think they are allowing multiple inheritance.
I think in Python it is allowing. C, we don't have the concept of classes, right?
No, ma'am, in C++.
C++
C++,
is fine. Yeah,
C++,
yeah.
wherever object-oriented programming is there.
Mm-mm. Right, right,
Only in Java, it is not allowed.
right.
Yeah. Okay, madam.
Yeah.
Okay.
So that's why we have to learn interfaces. most of
So
the
far,
things
this is
are.
only the 4.1 we are doing now, madam.
Mm-mm.
First lecture only.
Lecture. Yeah, first lecture. I think only the first lecture, I guess.
Yeah, first lecture only.
Yeah.
Ma'am, how do you access this static function
You have to
in the
use the shape interface name, then print shape. Shape dot print shape.
direct? We don't have to use the
Directly.
super keyword.
No, no, no. Okay. And then, what about having an interface and a class? So, a class can inherit a class plus implement an interface. Let's see one example for that. Abstract class. Hmm. So here you can see we have an interface 1, and an abstract class with a method 2. Here my class extends abstract class and it implements interface 1. This is allowed, extending one class and implementing another interface. But you have to see the order. You have to inherit the class first. You have to use the extends keyword first, and then you have to use the implements. Okay, and you can give the implementation for the abstract method from both interface and the abstract class. Rest of the things are normal. So here we have given implementation for method 1, implementation from interface 1, and for method 2 implementation from abstract class. Okay, is that clear? Okay, in this case, what do you think? If we have method 1 here, anyway, we'll give implementation. Uh, okay, what about having a default method in interface 1, default void method default dot okay, this is our default method from interface. And suppose our abstract class has a regular method like void with same name. So here, if I call obj dot method default, let's see which method will be invoked. We got an error, cannot hide the abstract method in interface 1.
Public we have to use, no?
Here, so where is the method? I think that is lost.
Line 24 you have to use public, madam.
Yeah. Right. 24, yes. Abstract class. Right, this is our default method from interface, and this is the regular method of abstract class. Here we have, here I have added, okay, let's not have this. Okay, but the public abstract method in interface 1. This is the problem. So in this case, we are getting error. And here, now, yeah, right. Okay, now see what I want to show is when we have same method name in both interface and abstract class,
Hmm.
then the
Huh?
then the method from the class abstract class will be taken, or the class will be taken into consideration. So yeah, Prof has mentioned that method from class will win, something like that. So that was, see here, method inherited from the class wins when we have both class and interface with the same method name. Got it? Any
Ma'am,
doubt here? Yeah.
ma'am, can you just show here once more, like which is winning?
Class only. So here see default method from abstract class.
Okay, okay. So even if the same function name
Mm,
is there in abstract and as well as in interface,
mm.
then from abstract it will do it, right?
Yeah, yeah. That is applicable for normal class also. Suppose this is not an abstract class, a normal class, and this has a method default, and interface has method default. If you use the method, if you call the method from the class will be called, not from the interface. Clear?
Yes.
Oh, so that's it. I think uh, most of the concept of abstract class and interface is covered. Yeah, this is the same thing about class shape. So here demonstrating the dynamic dispatch. Yeah, and this comparable interface, this we'll discuss later. Mm, okay. Yeah, this one thing. Interface is purely abstract class. Before Java 8, default methods were not included in interface, but now it's not. Now we have default methods also in interface, along with abstract methods and static methods. Class implements an interface. Yeah, we have seen that. Classes can implement multiple interfaces. Yes. Describe specialized capabilities. Hmm. So, what is the purpose of abstract methods or abstract functions? That simply says this is the capability of this particular interface. So, just to mention the capability or the abstraction, that one level abstraction where implementation is not given, is hidden from the user. So, that is about abstract classes and interface. Now, this also we'll discuss later. Dealing with the conflict we have seen. Uh, hmm, this also we have seen. Now, next topic is inner class. So, what is inner class? Consider. So, basically, in our course, we have to learn about the private inner class. Okay, private inner class. Okay, suppose we have class employee. Okay, and class employee is having some instance variables, and will have some constructor and normal methods, etc. And we can also include a class inside another class. See a definition of a class address. Here we have a class address inside class employee. So which means a class is containing another class. So the inside class. The class that is present inside the class is called as inner class. And here class employee is called as outer class. Class inside another class, that is inner class, and this is private inner class. So all this time we have nodes in a private class, right? We have seen only a public class and a no modifier class, a default class. And we cannot have a private class, a private outer class, but we can have a private inner class. And what is the use of this thing? So this is just to improve the protection or the encapsulation, that particular concept, where we can have a class uh, with some values which we want to protect, which we want to give an additional layer of protection. So that is the purpose of having a private class. And private class is having some private variables, and this is the constructor for the private class. This is the toString method. So when we print this particular address object, we will get in this manner. And how can we access the variables of a private class? So what is the accessibility of a private class? We cannot create object of private class outside this outer class. So the restricted or the visibility of inner private class is actually restricted to the outer class. We cannot do anything outside this outer class. Is that clear?
Ma'am, here you are saying that this private class address we cannot use this class outside of our outer class employee, right?
Yes, yes. Yeah, for now we'll learn from this. We have some other ways by which we will be able to access these things from outside. We'll discuss later, but now for understanding, you learn like this. Now, private class address cannot be accessed outside the outer class. So, how can we access the city variable? So, we can create an object of address. So, this is a reference variable address A, and here see a public method inside the class employee, and here this is taking a string variable. Okay, what it is doing, creating an object of our address class. After creating the object, using the variable, setting the value for uh, city. Okay, so this is
Hello.
done. Yeah,
Like here, city in address is private, right?
yeah, yeah.
And a private variable can't be accessed like outside of class,
Yeah,
outside of that class. So, like, how their city is accessible from outside the address class?
but this is special case where the outer class can access the private variable city after creating the object. We cannot access uh, just like this. This is
But
not
but
allowed.
like, ma'am, but it is still outside of that address class, no?
Yes, yes. Still outside of our private class, but inside the outer class. So they have that relation, kind of a special relation between the outer class and inner class, where outer class is able to access the private variable after creating the object. Okay, here I will show. Inside the private class, can we access name equal to something? Sorry, what happened? Why is it showing red? I can accept expected string name. Wait a second. Let's give some value here. Let's try to change the name So what I want to show is we can access outer class variable inside the private class, okay, and at the same time we cannot access this private class inner class variable outside the private class, but after creating the object we can access. Clear?
Within only that class, right?
Yeah, within only the outer class.
Okay.
Yeah.
And then what if like we create object of employee class, like outer class,
Mm.
and then we are trying to access the private class or private variable in the private class.
Yeah, then it's not possible. So you are saying we are creating an object of employee class, and here if you try to access, okay, I'll show you. So e dot here the variable is okay name. I'll remove this e dot name e dot name. Now we accessed name from class employee, okay, and at the same time can we access address variable e dot what is the variable name a dot city is the address variable from address object. This we cannot do. This is not accessible. Type employee dot address is not visible
Why, ma'am?
because it is private.
But we are not direct accessing the inner class, no?
And
First we
that's
are
no.
creating object class.
Yeah, but still it's not allowed. Outside the
Mm.
class it's not allowed.
Then how we will do? First we will create a method
Right.
to access that. Yeah, then
Yeah,
okay.
that's the right way. So here see this particular public method add and set address. So when we call the add and set address using the employee object, okay, and if you want to give some city value, you can give here, and here it will go create the object, add the city value. So now this is how you can access the variable. So here, what happened? Here again we are setting the value for city. This is how you can access and set the value for our private string city using a public method inside the outer class. So this particular constructor is going to take this Chennai and then set the value for
Um,
city. So when we print, we get city. Yeah.
like ma'am, like when we are doing e dot a, then we are not accessing direct, right? Because a is also like object.
No, no. Still, city is not accessible outside because it's private.
But creating object we can like access now, ma'am.
No, you are saying, suppose, okay, I'll show this particular example where we have a public class address. Okay. This is also an inner class, but it is public class, public inner class. And in this case, if you want to access a city, what you have to do is first you have to create an object of outer class, okay, and then using the outer class you can create an object of inner class. Now employee dot address a1 is an object of address class. Now if you want to access city variable a1 dot city equal to, is this allowed? Just check. See, here this is allowed. Why? Because this is public class. But while creation of inner class object only we have to take it. After that we can access. But when we make a class as private class, then that cannot be accessed outside the class. That's why we make it as private class. If we can access, then what's the point of making it a private class? We don't want to access this inner class. Then we will make it as private inner class.
Okay.
Yeah. So when we have to deal with some bank transaction or something like that, so we'll store the details of card details inside a private class like this, so that from outside we don't have the permission to access those details. Okay, is that fine for everyone? No response? Does that mean okay or not?
Yeah, it's okay.
Oh, so this is an example of linked list and node. Do you know what is linked list? Data structure. Have you gone through those?
Yeah, ma'am.
Okay. Yeah. So linked list is where the data will be stored in the node, and each node will have some address field also, data part and address part will point to next node. That's how these nodes will be connected together to form linked list. So we can make this node as private, and let's see one example. So here we have a class linked list, and here we have class node. Here node is actually a private class, and here we have a header node. For header node we have instance variable, and initially head is going to set as null, and here we have add method. It will create a node with the data that we give when we call the add method. If head is equal to null, it will create a new node and head will point to new node. And otherwise, we'll set the value for current node as head, and then we'll change the pointer just to maintain the linked list. So that's how linked list work. Current node will be set to the current nodes. Next means that address part will be set to the new node, and the first head node will point to the current node. Okay, that's how the linked list is built. Hope you know how that is built. And this is to print the linked list. So current node is set as head while current is not equal to null. Why we are doing this? Because the last node will point to the null, right? So till we see the last node, we are going to print the data, current dot data, and then changing the current node position to current dot next. So it will point to the next node, and printing out those data. Here creating linked list object, calling the method add, giving some value 1, 2, 3, 4. Now 4 nodes will be created. These values will be added there. Then calling print list method. Then this will print the values from our linked list. Something wrong. Mm, Load main class with the first example. In a class. What is it? So we have linked list 1, 2, 3, 4. So this is a simple example where we just show a private class node, nothing detailed concept. Is that fine? Inner class concept, this is a basic inner class concept. Now we have to go into detailed controlled interaction with object, those part. Is that fine till now?
Yeah, ma'am.
Okay. Then we will see. So private classes allow an additional degree of data encapsulation, combine private classes with interfaces to provide controlled access to the state of object. Now we will see this particular concept where it is called as controlled interaction through objects. So let's see one example and I'll show how it is working. Consider this particular example. Here what we will do is we'll mix both concept, interface and private class. Okay, how we can have a controlled interaction with the private class objects. Let's see. Yeah, first let's see this particular interface. What is this interface? Interface academics, and this interface academics is having an abstract method get result. Keep in mind, interface academics is having an abstract method get result. Now in class university we are having an instance variable. Okay, here we have a private class college. This is a private class college, and what this private class college is doing, it is implementing this particular public interface academics, implementing this particular academics. Okay, and now what this particular private class college should do, it must give an implementation for get result method, right? That is mandatory because class college is now implementing academics interface. Now here we have a private variable college name and another private variable college code. This is our constructor, college name equal to name and college code equal to code, setting the values for name and the college code. And then we have a get name public method. Okay, what is it doing? It is printing out the college name. And what is this get result method? This get result method is actually the abstract method that we get from interface academics, and we have given the implementation for that particular method where in the private class college, and here implementation is 100% passed. Okay, now see, so all of these things are inside the private class college. Okay, till here. Now we have another public method get reference. Okay, and what is it doing? It's creating an object of our private class college. Okay, creating an object of private class college with some values. Now what is the return type of our get reference? It is academics. What is this academics? Our interface, this interface. So we can use the reference variable of academics and point to private class object of college, right? So it is allowed. So what we are getting here, we will get an object of our private class college. Is that clear till now?
Ma'am, but this academics is outside the the college class.
Yeah. So academics is a normal, let's consider it as a public interface. It's a public interface now, academics. Now, private class college is implementing academics. So now we have the provision to create object like this, academics A is equal to new college. This we can do, right? Because
Yes.
parent class reference variable can point to child class object. So that that thing we done through a public method in outer class university. So we have a new method here, get reference method. In get reference method, we are creating an object of college, and the object is going to be pointed by an academics variable. Okay. Now the return type of this method get reference is academics. Now this can point to our object. Now what is the use of these things? We'll see in the another class.
So,
Okay.
ma'am, here, what is the reference variable here?
Academics.
Academics is the
Yeah,
reference.
yeah. Here we don't have a reference variable, just a method. We will take this object outside. Here we will take it. I will show you. So for now, you understand that this method is going to create an object of college, and an academics reference variable can point to that object. Okay. Even college is also fine. Anyway, now I am taking this academics, and we'll see how this is a controlled interaction. Now here see, we are creating an object of outer class university, new university. Uh, yeah, we are creating an object of outer class university. Now we have object name uni, reference variable uni, and now here see in line number 32, academics reference variable. We are creating a reference variable of academics, which is allowed because interface is public here, and using the object of university, this uni, we are calling the get reference method of university. Normal thing. We are creating object of university. Using that, we are calling this get reference method. Okay. We are calling the get reference method of university. And what is this get reference returning? It is returning an object of college. And now we are able to get the object of a private class, okay, through interface academics. Okay, and now academics, this particular variable is pointing to an object of the private class college, but this is made possible only because we had an interface academics which was implemented by our private class. And which method we can access using this academics variable? Only the get result method from the private class. Are you getting it?
Yeah, like ma'am, here, like
Mm.
we can't give the college reference to ACAD, right?
Yeah, yeah. Here we cannot, you're saying we cannot change this to college, right?
Yeah,
No, we can't do that. But here we can change. This is fine because it's inside the class university.
yeah. After changing there, we can do.
No, no, no. Even if we change here, college, okay, and if you want to make change here, this is still an error because college is private class. College
Yeah,
cannot be resolved at type.
right, right.
But as our college is implementing academics, now for we can call this get result method outside the class, outside the outer class also. So that is what it is called as controlled interaction through objects, which is allowed only with the help of interface. Getting it? Does that mean we can access get name method from our college? No. Still we cannot access other things from our private class, but we can access the get result method, which was abstract method from the interface academics, by this way.
So, ma'am, we can only access the abstract methods.
Yeah, only access the implementation that be given to the abstract method.
Okay, not the other method that
No,
private.
no, not the get name or other things from the private class, only the get result method.
So,
That's
ma'am,
why it is
here
called as controlled interaction. Yeah,
private class is also an inner class, no? Yeah,
yeah, private classes.
college is.
College is, yeah, inside the class university.
Yeah. So this is also an inner class, no?
Yeah, right. This is private inner class.
Yeah.
Ma'am, if this get name is also in this interface, then we can access.
Yes. Okay. So that is the concept of controlled interaction. So here,
So then, what is the benefits of this? Uh, what are the use case of this
yeah.
controlled interaction?
So this particular example is good example. Suppose we
Okay.
have a railway booking case where, okay, sometimes, yeah, in IRCTC, if you are using IRCTC, then you can you might have seen that only if you log in, then you will be able to book tickets and all, right? So they are checking whether you are logged in or not. So that kind of one control over when you use an application that can be brought by control interaction. Sorry, this private class and interface. So here see, this particular example is class railway booking, and here we have a method get status. Here we have a private class query object which implements an interface, public interface QIF, and this particular method get status is an abstract method from the interface. And if you give the train number and the date, okay, it will check whether login is valid or not, and then will give you the status of that particular train number and date. So that is how it is restricted.
Ma'am, hello, ma'am.
Yeah.
So this also happens in in e-commerce web app also. Like if an user is logged in, then only he can or she can order. So this can also be implemented in that also.
Yeah.
Okay.
To avoid spamming and some other cyber attacks, like where some spammers, what they will do is they will simply send request, and it will actually, if someone who actually wants to access the data won't get it because something will happen. So those kinds of things we can avoid by restricting in this manner. Bombarding, some term is there for that, forgot it. Yeah, so that is how. See here how it is restricting. See, get status method. If number of queries of so for one particular user, there is a limit.
That is called denial of service, no, madam?
Right. Yeah. So if we restrict some, okay, we maintain some for one user 10 requests in 1 hour, and if the number of queries is greater than 10, that person cannot get the status because they are doing it for some spamming purpose. Just consider like that. So to do some restriction over the user, we can use this particular concept. Is that okay? Hope it is fine. Okay. Can provide controlled access to an object, combine private classes with interfaces. External interaction is through an object of the private class. Capabilities of this object are, yeah, this capabilities is known through the public interface. So we saw only that method from the interface is visible to the user. Object can maintain instance variable to track the state of interaction and all. Okay, so uh, callback I'll take later in the Saturday session. Let's see iterator. Okay, so we have seen if we have if we have an array, how we will access the elements of array, how we traverse through the array using some for loop or while loop, right? So that's how we access. So one at a time we can access these elements of an array. And what is iteration or iterator? You might have seen in Python also. This is just like a pointer or a cursor that will be standing behind the first element, and whenever it will check whether the next element is present or not. If the next element is present, it will go and check, and then if you want to print, you can print. So there are methods that actually used to check whether next element is present or not, which is has next method, and also to print the element, we have next method, or you can consider now it as a print next. So that is how it works. So the thing is, we have to start. If we have an array or something like that, linked list, we have to start from the first element. Okay, and if there is a next element, get the next element, do something with it, just like a while loop here. And now the concept of interface. So how we allow this is, we have an interface called iterator, and the iterator has two abstract method, has next and get next method. So has next is returning as a boolean value, either true or false. If an element is present, it will return true. If element is not present, it will return false. And then get next method is going to fetch that element. So get next. So what is object? Object is the top level class in the hierarchy of classes. So get next method is going to return the element in the form of object. In the form of object, I mean, yeah, the type is object here. Now, we want to have a pointer to remember position of the iterator. So something like that we have to remember. And how we can add this iterator into our collection, like linear list or a linked list or array. Suppose consider linear list. When I say linear list, just think it's like an array. Okay, a linked list with having many nodes for collecting the data. What you have to do is, suppose we have a linear list, you have to add a private class, something called iter, which will implement this iterator. Which iterator? Our iterator interface. Okay, now this iterator interface is giving us two abstract methods, has next and get next method. Now you have to give implementation for these two methods, has next and get next. As this iter is a private class inside our linear list, we want to get this iterator outside. For that, you want to declare a public method inside the linear list. Okay, here you can create an object of inner class iter and then return the value. But while returning, see the return type of the method iterator, it is iterator. Because this is implementing iterator interface, this is allowed. Are you getting it, what I'm saying? Okay, if you have any doubt, you can interrupt me, okay? Now, yeah. After getting that iterator, we can just use that iterator to iterate through the list. How? Because this iterator has two methods, has next and get next. Using this you can call it dot has next and it dot get next to get the method, to get the element. And this is another example of interaction with state. And in collection, in week 6, you will learn about collection. And in collection, you will see how iterator is used in detailed manner. For now, you just have to understand what it is doing. And for quiz one also, it is important. Okay, this is our for loop. We have seen this. Anyway, I'll go to iterator. Hope I have an example. Looks like I don't have an example. One second, I'll find an example. Okay.
It's raining, madam, outside.
Actually, it came to Kerala, so but in Chennai it's raining.
Okay, okay. No, the sound, raining sound is we are able to hear.
Oh, maybe it's raining too.
Okay, no problem.
Is it disturbing?
No, no, no. I was just inquisitiveness was there to ask. That's all.
Okay. So, okay. See here. So this is our interface iterator. Okay, it has two methods, has next and get next. And this is printable abstract class. Is something more is there in this particular example. Anyway, so this is our product list, a class product list. So this is just like a collection. And here we have a limit 3, and here we have an array, product list array with the 3 product. So product is another class that has name and product ID. Now you should concentrate more on this particular case here, this line. Private class prod iter implements iterator. So this is implementing our interface iterator, and here this is having index, some index value. This is our constructor. This is has next method. This is get next method. Has next method, what is the definition given? If next element available in list, return true, otherwise return false. So when it goes through this particular array, if next element is present, it will return true, otherwise it will return false. So what will the next method, get next method, do? It will return the next element from the list. Now, this is a private class predator. So if you want to get an object, the same concept of control interaction through objects we will use here. We'll create a public method get iterator and return this prod iter object through iterator. And we can get this prod iter object through iterator. So here you see we are creating iterator, iter is equal to, we are creating it for our product list object. So that is our outer class product list plist, and plist dot we are calling the get iterator method, this particular public method. Then we are getting the object of prod iter, which is our original iterator, and then we will use a while loop. What this while loop will do, it will check whether iter dot has next is true or not. When it will return true? Only when the element is present in the next position. Okay, if it is true, then we can call get next method here. So how to call get next method, that you have to see. So here you can see, okay, So here you can see we have to print the method, print the object too. So iter.getNext, we are changing it to printable, typecasting to printable, which is an abstract class, so that we can call the print method. So that is only the one catch you have to remember. You have to typecast that particular object to printable to print it. Is that fine? Any doubt in this particular code? Is that fine? I hope it's fine when you are silent. Okay. Okay. Now, okay, for today I'm closing the topics, and okay, I want to ask how is your level in Java now? It's fourth week. Are you able to code yourself? Anyone?
Simple overriding, I can do. But week 4 concept are tough. I am not able to solve practice assignment for week 4.
You just take some 2 days to learn everything, or you just divide the concept and learn just abstract classes, interfaces. After understanding both nicely, then only you step into inner classes.
Okay.
Okay. And what do you think? You want any more uh, extra classes from us? Coding session, we will take more sessions for OPP anyway after quiz one. Uh, but still, what is your level? Are you able to do your practice programming assignments PPAs, not just PAs?
Until now, week 3 it was fine, but week 4 I am finding tough.
Yeah, for me also like like till week 3 it is good, but like week 4
Okay.
it is tough. Yeah.
Week four, it's a little bit difficult. Yes, yes, right. So, but your OPP won't be that difficult, but still you have to learn how to
Ma'am,
do
hello,
that.
ma'am.
Yes, yes.
In quiz one, so we expect the question related to data structure like linked list and queue, dequeue, all these like in Java.
Not linked list. The Java quiz one will be very easy. Questions will be similar to what you get in grade assignments and practice assignments. Those are simple, right?
Yes.
And also you can go through that folder in live session code, this particular section. We have added some previous question over there. Supplementary contents, live session code. Here you can go to this ET and this is higher level ones. Okay, I'll add it. I think it's not there. This one is not there. Okay, I'll add it. Okay, today I'll add. So, any other queries? Is everything fine in Java?
Yeah, ma'am, it's okay.
Okay. So, start learning from now itself. Okay. So, next week we'll